Hello friends, welcome back to the Python programming session. In the earlier session, we saw how we can perform arithmetic operations on arrays with constant scalar value and how to perform arithmetic operations on two or more arrays with same shape and size. So we saw how we can perform arithmetic operation on a single array with a constant value and also how we can perform arithmetic operations on two or more arrays with same dimensions. And in today's session, let's see how we can perform arithmetic operations on arrays of different shape and size. For this, today we are going to learn more on the broadcasting and the broadcasting rules. So if we have arrays of different dimensions, then we have to apply the broadcasting rules, and if it satisfies the broadcasting rules, the arithmetic operations can be performed, otherwise it gives out a value error. So let's look more into it in this particular session. So the term broadcasting describes how Numpy treats arrays with different shapes during arithmetic operations. So it shows how it treats NumPy arrays with different dimensions during arithmetic operations. Subject to certain constraint, based on some constraint, the smaller array is broadcast across the larger array so that they have compatible shapes. So the smaller array is broadcasted to the larger size of the larger array so that they have the compatible shapes. So what does the broadcasting rule says? If the arrays don't have the same rank, suppose the arrays are not of the same dimension, then we have to prepend the shape of the lower rank array with ones until both shapes have the same length. So in order to make it of the same length, we have to prepend prefix ones on the lower rank array. And also, while operating on two arrays, NumPy compares their shapes element-wise. It starts with the trailing dimension and works its way left. The two dimensions are compatible. When do we say the two dimensions are compatible? When they are equal or one of the dimension is equal to 1. So the arrays can be broadcast together if they are compatible with all dimensions. And if they do not meet these conditions, a value error throws up saying operands could not be broadcast together and an exception is thrown. So now friends, we have two arrays of different dimensions. A is a two-dimensional array and B is a one-dimensional array. A has got 5 rows and 3 columns and B has got 3 elements. Now can we perform arithmetic operation on these two arrays? So for this we have to apply the broadcasting rules and see if they satisfy the broadcasting rules. So the first rule says we have to prepend ones on the lower dimensional array. So let me say A equal to my A is equal to 5 comma 3, dimension is 5 comma 3, and B is equal to a one dimensional array with 3 elements. So how do we apply the broadcasting rules? B is a one dimensional array and A is a two dimensional array. B is of a lower rank, so we have to prepend it with 1. So we have to say 1 comma 3. So the rank becomes the same. Both are two-dimensional arrays. So the first rule of broadcasting is that to the lower dimensional array, we have to prepend ones so that the two arrays become of the same dimension. So 5 comma 3 is a two-dimensional array. 1 comma 3 also is a two-dimensional array. So this is the first rule. If the arrays don't have the same rank, then prepend the shape of the lower rank with ones until both shapes have the same length. Now we have to check the second condition. What does the second condition say? From the trailing end, from the right side, it checks this dimension. So it is 3, 3. So both are equal. So the second condition is satisfied for one of the dimension. Then it comes towards the left side and checks 5 and 1. In this, both are not equal, but one of the dimension is equal to 1. The B dimension is equal to 1. So it satisfies both the dimensions, that is 3, 3 and 5, 1 satisfies the rule of broadcasting. So we can perform arithmetic operations on this particular array. So let me take A as 5, 3, B as 1. Okay, dimension is 1. Okay. Now let me import Numpy as NP, and then my A is equal to np dot array. It's having 5 rows and 3 columns. So let me say 10, comma 10. Sorry. Import Numpy as np. A is equal to np dot array 10, comma 10, comma 10, comma 20, comma 20, comma 20, comma 30, comma 30, comma 30, comma 40, 40, 40, 50, 50, 50. So it's basically a two-dimensional array with 5 rows and 3 columns. And my B now is equal to a one-dimensional array. np.array 10, comma 20, comma 30. So it's a one-dimensional array. So we are making it as a two-dimensional array by prepending it with 1, and then we are comparing both the dimensions, that is 3, 3 and 5, 1. So in this case our B will extend 1, 3. It is having 3 columns and 1 row. So I'll extend till the 5 rows, and it will have 10, 20, 30 extended till 5 rows, so that it will become compatible with A. So now if I say print A plus B and run the code, we get the output, the following output, that is 10, 20, 30 has been added to each and every row. So 10 plus 10 is 20, 20 plus 10 is 30, 30 plus 10 is 40. Again this 10, 20, 30 is added to this row, this row, this row and this row, and finally we get this following output. So even though the dimensions are unequal, if they satisfy the rule of broadcasting, then we say that we can perform the arithmetic operations. And now let's see what are the broadcastable arrays. So now let's see what are the broadcastable arrays. So suppose this we have seen 5, 3 and 3. Now let's move on to 5, 4 and then 1. So 5, 4, let me write it over here. A equal to 5, 4 and B equal to 1, 1 comma. So in this case, B is of a lesser dimension. So we have to prepend it with 1. So we'll say 1 comma and make it of the same rank as the two-dimensional array. And now let's check from the trailing end. 4 and 1 dimension, one of the dimension is 1. So the condition satisfied. Now let's move on to 5 and 1. Between 5 and 1, one of the dimension is 1. That is B is having one dimension. So the rule of broadcasting satisfies and we can perform the arithmetic operation on this particular array. Now let's move on to one more example. Let's take a three-dimensional array 4, 3, 5. B is equal to 4, 1, 5. So this is 4, 3, 5 and B is 4, 1, 5. 4, 1, 5. In this, we both of them are of the three-dimensional. So we need not prepend it with ones, because they're of the same rank. But the dimensions are different. So we have to come from the trailing end and check each of the dimensions. Here A is 5, B is 5, so the rule satisfies. Here A is 3, B is 1, so one of the dimension is 1, so the rule satisfies. Here A is 4, B is 4, both of them are equal, so the rule satisfies. So we can perform arithmetic operations on this particular array. And now let's move on to the fourth one, that is 12, 3, 5 and 3, 5. So 12, 3, 5 and 3, 5. So friends, here So here 12, 3, 5 and 3, 5. A is a three-dimensional array and B is a two-dimensional array. So we have to prepend it with 1. So it becomes 1, 3, 5. Now from the trailing end, we have to check the dimension. 5 is equal to 5, so it satisfies. 3 is equal to 3, so it satisfies. And 12 and 1, one of the dimension is equal to 1. So even this satisfies, and so we can perform arithmetic operations on this particular array. And lastly, we have last example is 12, 3, 5 and 3, 1. So friends, here also we have A as three-dimensional array and B as a two-dimensional array. So we have to prepend it with 1 to make it three-dimensional array. Now 5 and 1, one of the dimension is 1. So it satisfies. 3 and 3, both are 3 equal. So it satisfies. 12 and 1, one of the dimension is 1. So it satisfies. So it becomes a broadcastable array and we can perform arithmetic operations on this particular array. Now non-broadcastable arrays. Non-broadcastable arrays. So here we have A as 5, 3 and B as 4. So friends, we have A equal to 5, 3 and B is equal to 4. So here, let me make it marked down. So A is a two-dimensional array and B is a one-dimensional array. So we have to prepend it with 1. And now we have to check 3 from the trailing end, we have to check the dimensions 3 and 4. The rule does not satisfy because 3 is not equal to 4 and one of the dimension is not equal to 1. So both the rules are false in this particular scenario. So it becomes a non-broadcastable array. Now let's see how it works in Python. A is 5, 3. So and A is 5, 3 and B is having 4 elements, that is 10, 20, 30, 40. It's a one dimensional. So let me copy the same code. Sorry, let me write it once again. A equal to np dot array, then we have 10 comma 20, 10 comma 10 comma 10, 20 comma 20 comma 20, 30 comma 30 comma 30, 40 comma 40 comma 40, 50 comma 50 comma 50. So this is my two-dimensional array. A is a two-dimensional array with 5 rows and 3 columns. Now my B is equal to np dot array, and I'm having 4 elements 10 comma 20 comma 30 comma 40. Now I want to perform arithmetic operation on A and B. So let me give print A plus B and run the code. It gives a value error because it's a non-broadcastable arrays. It does not satisfy the rules of broadcasting. It says operand could not be broadcast together with shapes 5, 3 and 4 because the dimensions are unequal and it does not follow the rules of broadcasting. So friends, these are the different examples for broadcastable arrays and for non-broadcastable arrays. So hope so friends, it is clear for you how we have to apply the rule of broadcasting if we have arrays of different dimensions. If the rules of broadcasting satisfies, we can perform arithmetic operations on it. Otherwise, we end up getting a value error and an exception is raised, indicating that we cannot perform arithmetic operations on non-broadcastable arrays. So let me just wind up. Before that, let me go through the broadcasting rules once again. If the arrays don't have the same rank, then prepend the shape of the lower rank with ones until both shapes have the same length. And secondly, we have to check for the dimensions. Both arrays are compatible if they have equal dimension or one of the dimension is 1. In this case, the arrays can be broadcastable, otherwise we get a value error indicating operands could not be broadcast together. Hope so friends, it is clear for you. If you have any doubts, please do reach to me out in the comment section. If you like my video, click on the like button and please do subscribe to get notifications of my new videos. Till then, see you. Bye bye.